Welcome another session of electricity. So in this session we are going to revise entire electricity for class 10 in another 30-40 minutes. Okay, so since the exams are going to start soon, so we'll have focus in mind, not the subjective one for this particular session. Rather we will focus mostly on the objective types of question. Okay, so as you all know, in upcoming session we are going to have a lot of questions from objective side, and electricity is one of the chapters plays a very crucial role. Okay, so let's not waste time and straight come to the topic. Okay, so this is for class 10 board exam. Okay, fine. So class 10 board exam is what? Fine. So class board exam is basically it is charge class 10 board exam electricity, and it has around 6-7 marks weightage. Okay, so the first thing is what is charge. Okay, so charge is basically is a fundamental particle. Okay, so charge is basically fundamental particle which basically of an atom, or it may be positive or negative. So charge is what? Charge can be positive or negative. Fine. Okay, and we know that the same charge, the repel and the opposite side. So it is the fundamental particle of an atom. Okay, if I talk about the atom, so we have to talk about the charge. Okay, and as we know, an atom consists of electron, proton and neutron. Okay, so electron, proton, neutron, and this is having negative charge, this is having a positive charge, and it has a no charge. Okay, it has a no charge. So basically in an atom, once we have a positive and negative charge, means we have electron and proton. Okay, now what is the unit of charge? Charge of unit is coulomb. Okay, and 1 coulomb is equal to 6 into 10 to the power minus 18 electron. Okay, electrons. Okay, and since it is charge of 1 electron, so we take it is 18 or 19 coulomb and so on. Okay, and one how do you calculate charge? So the major formula is Q is equal to N into E. Okay, where N is number of electrons. So if in exam it asks how do you calculate the charge of an electron. Okay, how do you check charge of an electron? So charge of an electron we calculate by this formula. If we have the number of electron in a circuit and we multiply with the charge of electron, which is 1.6 into the power minus 19 coulomb, so we'll get the total charge. Fine. Now after charge comes the current. What is current? It is rate of flow of charge. So when I say current in the circuit, I talk about normally the charge which is following in the circuit. And what is the current? Current is equal to charge by time. Okay, current is equal to charge. So what is charge? Charge is, what is charge? Charge is Q by T. Therefore I say I is equal to Q by T. Now what is the unit? The unit of charge is coulomb. Okay, and the unit of your current is ampere. Okay, so these are things you have to remember. Okay, and these are 1 ampere is equal to 1 coulomb per second. 1 ampere is equal to 1 coulomb per second. Okay, so there are other units. Okay, there are other units through which we can basically calculate the current. One is micro and one is mu. Okay, so and normally in exam ask like what is the ammeter symbol. This is the ammeter symbol. They might ask you, so what is the ammeter? Ammeter is the low resistance, it is the appliances, and it's always connected in, so ammeter is always connected in series. Okay. Now the next direction of the current. Now we talk about the direction of the current. So how we take the direction of the current? So the direction of current is always taken opposite to flow of electron. Okay, as electrons was not, but if you just say it's opposite to flow of current. Okay, and so this is the one objective question normally they ask. So what is the direction of current? It is the opposite direction of the current. Now the next topic is your potential difference. So what is the potential difference? Okay, so potential difference, so in everything now focus is more on the current syllabus. So you in general you might find something which is not in sync, so but and assure that I'm assuring whatever is there in the syllabus I'm covering and focusing on in those only. Okay, so what is potential difference? The potential difference is basically work done to move one unit of charge. So if there is a 2 point A and B and the work is done to move one unit of charge from point 1 to point B is called potential difference. So it's a work done to move one unit of charge, okay, one unit of charge. Okay, and how it is said? It is formula is to calculate this one. V is equal to W upon Q, and V is the volt, so charge. So 1 volt, the unit is joule. Okay, so 1 volt means when 1 unit of work is done in carrying a 1 coulomb of potential difference is called 1 volt. Okay, so 1 volt, if I put the volt is 1 volt is equal to 1 joule upon 1 coulomb. Okay, so it is, so 1 volt is equal to 1 joule per coulomb or -1. Okay, so they might ask what is 1 volt. So must remember that 1 volt means 1 joule work is done in carrying 1 coulomb charges. Then potential difference is called. So if 1 joule of work is done to carrying 1 coulomb of charge, okay, so then the difference is potential difference is called, it is 1 volt. Okay, and the voltmeter is the instrument which is basically we use for measuring the potential difference. Okay, so as I said earlier, the ammeter was connected in a series. It is always connected in a parallel. Okay, and what is the simplest device to maintain potential difference? So these are the important point. So simplest device through which we can maintain the potential difference is our cell. Okay, and one thing very much important for project, you always remember that what is the flow of current. So once I said opposite to the direction of the current, and second the flow current always flow from higher potential to lower potential. So if you remember in the classes what we have learned, that example of the water tank. So water normally flow from the upper side to lower side. Okay, so simply the current always flow from the, and that is the one of the best example of potential difference. Now here I have put in some of the diagrams which is very important. They might ask in the objective question. You can't be very much sure this will come, this won't come. Okay, so this is not something to very much explained upon. Okay, so I hope you guys can look into your NCERT book or the reference book just to ensure that is registered in your mind. Fine. Now the next important topic is Ohm's law. So what is Ohm's law? So Ohm's law is basically what is called the flow of current. Basically it is, let's say what we say, it is the potential difference across 2 points of the metallic conductor is directly proportional to the current passing. So it is the potential difference is directly proportional to the current path. So if potential difference is V and current is I, so in across 2 points of the metallic conductor, the potential difference is always directly proportional to I. What does it mean? It means that if the potential difference increases, the current will be increases, or the current will increases, potential difference increases, and the vice versa. Okay, or we can say V is equal to IR, where R is the constant, which called resistance of a given metal. What is the given metal? The metallic point through which the current is moving at that point of time. Now this is a very much famous VI diagram. Okay, so this VI diagram is what? This VI diagram is basically potential difference current diagram. Okay, so if I plot a graph like this, one side if I say current and other side I say potential difference, if I say I divide the unit, okay, it is ampere, 1 ampere, 2 ampere, 3 ampere, 1 volt, 2 volt, 3 volt, and if I draw a graph, that is the very famous experiment is given in your book. I hope you, just for the revision, I'm just putting it again. Okay, so it is how it looks like. It will be, if you draw with all the point, you will find a straight line. So this is very important. A lot of variation questions are being asked in this, but if you this is the standard graph. I'll do when exemplar and NCERT question, I'll discuss some question here, but in Ohm's law is very much important in a subjective point of view also. So only you remember the potential difference is directly proportional to the current passing through the current. Okay, now the next point is resistance. So here we found a resistance which is a constant. Okay, so if I say, so what happened? So when the current is flow in particular circuit, few currents are lost, and that loss is because of the resistance. This is kind of the friction we have discussed. So what is resistance? Is the property of current which resist the flow of charges. Okay, so that is the reason we say all the charges are not transferred when we move from one place. So few charges is lost in the journey. Okay, but the important point is, what is the unit for resistance? Unit for resistance is ohm, and it is indicated by this symbol. Okay, so and now the component which is used to regulate, so loss of current, the current is lost, you have to do something to get the current back. So what is resisted is the device, is the variable resistance a company used to regulate the current without changing the source of the voltage. Okay, that is very good, excellent. Now the one very important point, what is the factor on which the resistance depends. The conductor of resistance depends. So number one, it is the length. So the longer the wire, the longer would be loss in current. Number B, area cross section. Number 3, temperature. And number 4, which is very important, which is called nature of material. Okay, so these are the few things which are very important. Okay, so it is length, area, temperature, and finally the nature. Okay, now the SI unit is ohm meter. Okay, and resistivity do not have any charge, so few points I have put it down here. The resistivity do not change with the change in length or the area cross section, but change with the temperature. Okay, now range of resistivity of the metal alloys is from 10 to the power minus 8 into 10 to the power minus 6. So and the formula is here, R is equal to rho L by A. Okay, okay. So resistivity do not change, okay, but the resistance is depend upon these all. So resistivity do not change with the change in length or and the change in temperature. Okay, now the resistivity of insulator I given. This is the resistivity of metals and alloys. Okay, another one is insulator. 10 to the power 12, 12 to 10 to power 17. Okay, okay. Resistivity alloy is generally higher than that of the constituent materials. Alloy do not oxidize or burn, and that is the reason why so they are commonly used in the electrical heating devices. So why alloys are here? So here this point, resistivity of alloy is generally higher than the metal, and that is the reason why the alloys are used as a electrical heating devices. So why? Because they do not oxidize. Okay, because alloy do not oxidize, okay, or burn, and that is the reason we use alloys for heating material appliances. Now we are coming very close to the chapter. Now two things are very important. Two things are very important here. One is very important point, which is called resistance in series and a resistance in parallel. So what happened when you put the resistor into in the series, okay, and when you have to find out when two or more resistors are connected end to end, this arrangement is called combination. Say for example, I put this resistance one after another, okay, so this combination I will call as a series. Okay, now in series few points you have to very important. So if this is R1, this is R2, and this is R3, so how you find out the equivalent resistance or the effective resistance? So effective resistance, if I say R, so R is equal to R1 plus R2 plus R3. So when you sum up the resistance of all the three resistance which is combined or connected in a series one after another in the series circuit, so if you add three of them, you will get the equivalent resistance. Now equivalent resistance is higher than the largest individual resistance. Okay, so why it's so? Because if it is 5 ohm, it is 10 ohm, this is 15 ohm. So R would be what? 5 plus 10 plus 15. So it will be 30. So the equivalent resistance will be always higher than the highest individual resistance. That's what I'm saying. Fine. Second, what it says, total voltage is equal to, what is the total voltage in the circuit? So total voltage is the sum of voltage drop. Okay, means what? If you want to calculate the total voltage, so V is equal to V1 plus V2 plus V3. Fine. Now this is the derivation I have given, which already you have done. So to how to, so we say V is equal to IR, so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Okay, and since I say total voltage is equal to V is equal to V1 plus V2 plus V3, so if I combine all of them, so what I say is equal to IR1 plus IR2 plus IRT. If I take I common, so it will be what? It will be R1 plus R2 plus R3. Now V is equal to kya? V is equal to IR. So if I put IR, I will be cancelled. So R is equal to R1 plus R2 plus R3. So this is not the intent I wanted to teach you, but I just wanted to show you how we have done it. Okay. Now the next is resistor in the parallel. Now what is resistor in the parallel? Okay. Now resistor in the parallel means what? If they are in parallel, so the total resistance, only you remember 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So since in the case of resistor, in the case of parallel resistor, the voltage across each resistor is same and equal. Okay, and so total sum of current is I is equal to I1. So in case of here, we normally if you want to sum the current, because if the current I is coming from here, here will be I by 3, here will be I by 3, here will be I3. Again they will come. So whatever the current will come from this point, the same current will be going off once they come out of the parallel connection or parallel circuit. So if you again you add these three, I by 3 plus I by 3 plus I by 3. So if you take out, it will be I only. So if you started with the I and you end with the I. So that's what I say, the current is equal to I is equal to I1 plus I2 plus I3. Fine, I think it's clear. So I'm going little in hurry. So because you have to revise lot of chapter. Okay, so you have to understand this point. So here I sum up all the current and here I sum up all the voltages. Okay, now equivalent resistance in case of parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the objective section. So this should be enough. Okay, now one thing, the equivalent resistance is less than the value of the smallest. Just reverse what we discussed in the case of series. Okay, now next point is advantage of parallel combination over the series combination. What is the advantage? Component fail. Suppose you have bulb, you have freeze, and you have, suppose you have a freeze here. Okay, freeze, here you have a bulb, and here you have a heater. So what happened? And they all are connected into series. So when they are into current, the freeze will work fine, the current will pass from here. Moment will come to bulb, and suppose the bulb got fused. So what will happen? The connection will break here only. Okay, so first time it will take in, first time the freeze will okay, but moment the current will pass from here, it will switch on, but immediately it will switch off, because moment the circuit will go, the circuit is not complete. So what happened? Because of one appliance, entire circuit is broken. So that's what say in the series, when one component failed, the circuit is broken. Second, different appliances have different requirement of the current. This cannot be satisfied. So this need, suppose 300. Okay, this needs 200. Sorry, 50 watt bulb is there. Is a 300 watt, and this is say 1000 watt. So this requirement is not fulfilled in case of series. Okay, because every appliances need a different requirement of the current. Okay, and finally the total resistance in a parallel circuit is decreased. Fine. Okay, now the last we have put the heating effect of current. So what is heating effect of current? So I'll again say, I'll not get into a lot of deeper concept, but when you use an appliance for some time, what you find? You find current is hit. Current is hit. So current is hit. How would current is? The appliances got little warm after some time when you use. So that you experience when you touch freeze or something from the outside. Okay, be cautious on that touching. There should not be any earthing and all misplaced. You might get a shock. Okay, so what is heating? If the appliance is purely resistive, the source of energy continually get disappear entirely from the heat, and this is known as the heating effect of current. Okay, and how do we calculate? How do we calculate? Energy is equal to P into T, and which is equal to VIT. Okay, and heat produced is equal to H is equal to VIT. Okay, and V is equal to is what? IR. So H is equal to IR into IT. So H is equal to I square RT. Okay, this is heating effect of current. And what basically heating effect of the current. This is proposed by Giuseppe, also known as the Joule's law of, is this particular concept is proposed by Joule's of law of heating. Okay, so it states that heat produced in the resistor is directly proportional to square of the current. So H is equal to proportional to I square, and similarly the directly proportional to H is directly proportional to resistor. Okay, and the last few points are very important, like heating effect. Heating effect is desirable in devices like electric heater, electric iron, electric bulb, etc. Okay, in electric bulb most of the power consumed by the filament, and if you touch the bulb from the outside you will feel heat. Okay, and that filament of the bulb is basically made of tungsten. Okay, and it is not oxidized readily at high temperature. Okay, and the last point, what basically which is very important here, which is electric fuse. It is, what is fuse? Okay, so fuse already we going to discuss in magnet. Okay, but here for some point it is a safety device that protect our electric appliances. Okay, so if more than the desirable current is passing from a electrical fuse, what it will do, the fuse will disconnect. Nowadays we don't use the electric fuse, we use the MCB. So MCB got tripped. Okay, fuse is made of pure tin or the alloy of copper and tin. Fuse is always connected in series with live wire. So if anything goes wrong, so it will avoid any kind of short circuit and all. So this may cause accident at home. Okay, so this is the what something, and the last, which already we discussed, but for the reference once again I am putting, what is the electric power. So power is equal to, power is rate of which energy is consumed. Okay, so P is equal to VI, and we already seen V is equal to IR. So P is equal to I square, I square R. Okay, fine. Okay, or we can so and what is the unit of power? Unit of power is watt. Okay, so 1 watt is equal to 1 volt into 1 ampere. Fine, and this is the commercial unit. So these are completely, what is the commercial unit? 1 kilowatt. So what is the in household, how do you measure the electricity? You measure the electricity in case of 1 kilowatt. So 1 kilowatt is equal to 3 into 6 into 10 to the power 6 joule. Okay, so 1 kilowatt hour is equal to 1 unit of electricity. Fine, so I have tried to cover all these small points. Okay, so see, look at, if you, when you read this concept, so that will cover each and every questions, objective question you can expect in the exam. Okay, so with this I am closing this session. Okay, but we will do some more exercises from exemplar and all, so this concept will be more clear. Okay, keep watching and subscribe us. Thank you very much.